Hello everybody. In this video we're going to be taking a look at percent equations where we're finding a missing percent. We've seen different variations of this problem where we're either finding a quote-unquote part, finding the smaller piece, finding the whole or the original part, and then this is our third and final variation here where we're finding the missing percent. We're given all the numbers and we're trying to figure out what percent is being represented. So we're going to look at more of a word problem approach here. It says, of the 400 students in 6th grade, 250 of them voted for a new vending machine. What percent of students did not vote, let's assume, for that vending machine? So there's a few things at play here. First of all, we're noticing that the 400 here is going to represent our whole. So just a little reminder here, we have quote-unquote part over whole equals percent over 100. So obviously this is a finding a percent problem. The percent symbol there is going to be our variable, what's missing. The whole here is going to be the 400. It's 400 total students. We're just dealing with 6th graders. There's no other variables. It's not like we have to find every other student in all the other grades or something like that. The percent is going to be our variable. We'll call it x. The part here is not going to be 250. And you might say, why? Because that's the only other number we see in this problem. A little trick here. It says 250 voted for a vending machine. We ultimately want to figure out what percent did not vote for a vending machine. So we can do one of two things. We can adjust it right now and just simply figure out that, all right, if 250 people voted for the vending machine, that would mean 150 did not, which is how we'll do it. The other way to do this would be, let's say if you accidentally plugged in that 250 and then didn't realize it till later, you could still use that answer. You're going to get, let's just make up a number and say you got 70%. You would just have to find the complement of that and say, all right, it's actually 30%, like the missing component. But we're going to adjust it in the beginning. Always a good idea. And now we have a proportion on our hands. We could do a few things here. We could cross multiply to solve. We can realize that, hey, this is being divided by 4. So I could simply divide 150 by 4. That would be like a constant of proportionality. Instead of dividing by 4, you would want to say multiplying by 1/4, but it amounts to the same thing. So 4 into 150 is going to give us our answer, which we'll pretend that we don't have a calculator available. This is going to be 4 into 30 is 7, which is 28. 7 times. And 4 goes into 20 evenly 5 times. So 37.5 we get. So if you did this problem, if you paused this video in the very beginning and you did this on your own and you got something, what would it be, 62.5%? Right? Yeah. That's obviously not the right answer. That would be representing the percent of students that did vote for it. So you're on the right track. You just fell for that little slight trick here. This word not is what really kind of messed things up a little bit for you. But like I said, even if you did realize that at the very end, you don't have to go back to square one. You can just simply adjust your answer to say, all right, there's only 2 possibilities. You can only vote yes or no. So we're allowed to do this. And just simply subtract. And you'll get the correct answer that we arrived at. Okay, so this was a percent equation with finding the percent. All of these 3 different types that we talked about utilize the same setup, the same proportion setup. The very first thing we mentioned. In this case, we were looking for a missing percent. And solving the proportion, you could either cross multiply or do some type of COP, constant of proportionality application. Thank you guys for watching.